the main thing is thank you for the invitation. It's been a wonderful few days. The research that I'm going to talk about has been going on about 5 years. I have an interest in materiality and the way that landscape architects have used materials, and particularly since the modern era. And I admit this is very American-centric. You know, Americans, it's a very big country, and so to try to look at the entire world in terms of landscape materiality is a little bit more difficult and more time-consuming than I had in the beginning. There we go. Okay, great. And I'll try to speak into the microphone and not turn around too much. And so what I found, and I started to look at some of the innovative material use of the American modernists, and then comparing it with today, where there's, in America and around the world, I think there's an explosion of innovation in material use. We have new technologies and we have new materials, but people are also using traditional materials in more innovative ways. I think this thing is still moving. I'm trying to hold it. And so that led me to Dumbarton Oaks to primarily look at modernists, American modernists, the people that I'll talk about. But one thing that happened while we were there is that Christina, in just the 2 weeks, she pointed me to a different, kind of a different direction. Instead of going from the 1950s to present day, she had me to go back in time, which unfortunately added more time to the supposed book that I'm working on. I was thinking a 5-year project, but it became a 10-year project once I started looking back in time. So these are a couple of things: materiality, innovation, and convention. What I mean by those, and those are the things that I have looked at in this 60-year period. And the method began with interviewing contemporary designers. I was really interested to meet Adrian Hudza from West 8, several Americans, a couple of French people, to actually just sit and talk with them about how they use materials, what was their inspiration, what would be helpful for faculty researchers to help them, because practitioners, unless they teach and are able to do research, most of the time they have to rely on others for some of their material research information. And as faculty, it's our responsibility, I think, to help any way we can to advance the profession. So I'm not sure how much American landscape history you know of. I know the students I think know Homestead. We discussed that a couple of days ago. These are the 3 guys that in our history of the U.S. began to break away from the Beaux-Arts school, the Beaux-Arts style that was prevalent. It was the country estate era where landscape architects were designing big estates for very wealthy people. The architecture school at Harvard brought in Walter Gropius from the Bauhaus, and he brought European modernism and architecture to the U.S. So these 3 guys, that's Garrett Eckbo on the left, Dan Kiley in the middle, and James Rose. They were at Harvard in the late 30s, and one of them was kicked out, one graduated, and one I think eventually graduated. But they gravitated toward the architecture because the architects were doing something very different. It was very new. And they really liked what they saw, and so they broke away, much to the dismay of the landscape architecture faculty. And they began to kind of cause a revolution in American landscape architecture. There's another guy that was in California. He was at Harvard 10 years before the 3 guys, and he was back there doing work, and he was doing the same thing. He was he was breaking away from the Beaux-Arts, the sort of orthogonal geometry, no curves. That's Thomas Church in the upper left. That's in his later days in one of his gardens. He never expanded beyond primarily residential gardens. And Lawrence Halprin worked for him. Robert Royston worked for him. This is a very bad photograph, but this is Lawrence Halprin. This is Thomas Church, and these are some other people in the office. So this guy was kind of independent of the other three, but they ended up. Ekbo and Church ended up working in the Bay Area for many years. They were very in tune to the modern art movement. People like Kandinsky and Paul Klee and Juan Miro, and they not only were starting to think about landscape design in a different way in terms of the spatial organization, they began to develop a new representation method. The way that they drew trees, the way that they drew landscapes was very, very different, and it sort of follows that when we begin to do something new in the design world, the way it's represented, it needs to change as well. And you can see the similarities in this. This is a Garrett Ekbo residential plan. Alvar Aalto, the Scandinavian architect, he designed furniture, he designed this famous vase. Thomas Church, his wife in San Francisco, was the first person to import Aalto furniture into the U.S. He had a furniture store specifically to import the furniture and the things like these, the glassware that he did. Miro, with this kind of really crazy geometry, these curves and shapes that were very playful. This is Thomas Church's most famous garden in the United States. It's in Sonoma County, just north of San Francisco, in the Bay Area. And you can see the representation is different. The curvilinear geometry is becoming prevalent. And as I said, when we were at Dumbarton Oaks, this was our private garden. This is a famous garden by a woman landscape architect, Beatrix Farron, who, like most women, was never recognized in the history books, because the history books in the U.S. were written by men. Norman Newton was a professor at Harvard, and he wrote the sort of textbook that I used in undergraduate school. And there are certain people that weren't there, and primarily women. And now Beatrix Farron has gotten recognition. She designed the Dumbarton Oaks estate, and it became property of Harvard in the 1940s. So if you ever have a chance here in the U.S., you should go visit Dumbarton Oaks. So what Christina pointed me to was a landscape architect by the name of Fletcher Steele. And he was working in the late 20s, early 30s, all the way up into the 60s. He, as I learned when I started to study him, he was a transitional figure in America between the Beaux-Arts and the modernists. The modernists, Kiley, Ekbo, and Rose, all knew of him because he was a prolific writer. He was starting to experiment. He was, had one foot in modernism and one foot in the Beaux-Arts. He began to introduce curves. Now, this is in 1929. His most famous project called Nomkeg. This was a big estate, the Choate family in the Berkshires in Massachusetts. But the important thing that he did, he was a practitioner, but he was also a writer. He was very prolific. He published in House Beautiful and Landscape Architecture magazine, and he went to France. And so how he began to bring back these modernist ideas was through his travels to France, because the French were experimenting a lot with materials and with the design principles of landscape and of gardens. And this is one of the articles that he wrote in House Beautiful. So these three guys, they were reading this stuff and finding out about the French, and then finding out about Fletcher Steele. And Dan Kiley, who is probably the better known of those three, he worked with all the great architects. He did the Miller Garden with Eero Saarinen, did the residence. He did the St. Louis Arch, the big arch monument in St. Louis. He did the Air Force Academy campus. And he was around just a couple of years ago. And he said that Fletcher Steele was the only person doing really good design in the 20s and 30s. And Ekbo said that this guy was an experimenter. That's what drew them to this guy, because he was willing to break out of the mold and do things that other people hadn't done. He experimented, as I'll show you, with materials as well as form and shape. Some of the French landscape architects and architects that were doing landscape that were impressive to Fletcher Steele. This is in an expo in 1925 in Paris, and this is these trees are made out of cast concrete, which is was very, very weird for the time. Even today, people would think that's pretty crazy to make these abstract trees, but Fletcher Steele really liked them. He thought there was nothing really unusual about this. This is Pierre Legrand. He's another French designer. He began to break away from the formality of the axial alignment. He introduced diagonals, and he also introduced the zigzag, or the sawtooth edge, to break up at least one side of an axial alignment. And so Thomas Church picked up on that, and he started to experiment. This is an exhibition in San Francisco that the Museum of Modern Art did. And they invited several designers to do demonstration gardens, and this is one of the ones that he did, clearly influenced by these other guys that were doing it in France. This is a church garden, a drawing from the garden, where he did the same thing. And in fact, Garrett Ekbo saw some of these gardens, and he actually said that he started to trace them just to get an understanding of the scale and proportion and how he might introduce them. These zigzags into his design. So what I'm going to do, the way I've organized this research is to look, instead of looking at specific time periods, I'm looking at the material, and I'm going to be going back and forth in time. But I think it's the clearest way to understand it. And I'm not covering everything. Obviously, we'd be here for a couple of days, and so in terms of metal, this is the garden that got me started and got me interested in this idea of innovation. This was in the 1950s in Garrett Ekbo. It's called the Alcoa Forecast Garden. The Alcoa Aluminum Company in Pittsburgh in the United States. After the war, they had lots of aluminum because they weren't making aircraft anymore for the war effort. And so they had this idea that they wanted to make some pieces out of aluminum that might be used in residential gardens. So they hired Garrett Ekbo. He was an up-and-coming landscape architect on the West Coast. They hired him to design a garden of these screens, expanded and perforated aluminum structural members. And so he designed the garden. This is one of his working drawings there. And that's the drawing of the garden. This is actually his home in Los Angeles. He lived in Los Angeles for a few years where he had his practice. He made a fountain that's an abstraction of a flower with the water jets as the pistils and stamens. And if you look at, this is a cardboard maquette. This was long before computers and AutoCAD and the machine that can figure out complex shapes. Frank Gehry comes to mind. You all know Frank Gehry, the architect. He in order to do what he does, he borrowed CATIA software that was used to design the French Mirage jet airplane. And so he was looking at these shapes that reminded him of these shapes that were very difficult to draw. And so that's how he began to do it. Well, before that, you could just cut things out of cardboard, put it together, and then you just flatten it out on the floor and put a lot of paper around and trace it. And so that's how they ended up being able to build this complex shape. And there's the drawing that they traced around. So this is some of the publicity. The Alcoa advertised on television. Remember, the American television. When I was growing up, TV came on at 5 o'clock at night and went off at midnight, and there were Sunday shows, and big corporations like Alcoa did advertise them. So there were these weekly shows, and so they were able to publicize this quite a bit. It was a symbiotic relationship between a manufacturer and a designer, which is something that I'll talk about in the end. We're getting back to this collaboration between fabricator and designer that we used to have back in the old days when we had real craftsmen, masons, and you still have that here. We've lost it a long time ago. We can't rely on craftsmen as much, and so we have to do many more drawings. But this relationship that he developed helped him. It got a lot of publicity from him, and he got more work and became more famous, and they sold a lot of aluminum. There was other artists that they got involved to use aluminum. This is Isamu Noguchi. He's a Japanese-American sculptor and landscape architect. He designed an aluminum stool that was part of the same effort to get people to use aluminum. And then there was Raymond Loewy, who was a very famous industrial designer in California in the 30s and 40s. He had designed aircraft. He had designed some of the first passenger airliners, and so he understood aluminum from that work, because aluminum is very light and it's very strong. So Sears Roebuck and Company, I think they're completely out of business now. Sears is a very big company in the U.S. You may know the Sears Tower in Chicago, the big building. That was the highest building in Chicago at one time. It's no longer Sears. I don't remember what it is, but he designed a refrigerator. They hired him and they said, we want to make a modern refrigerator. And he used aluminum because it's very lightweight, you can move it around, and it's very strong. And this was the biggest seller of Sears Roebuck and Company for many, many decades. And I think only in the last 10 or 15 years did they stop manufacturing the Sears Cold Spot refrigerator. So jumping ahead to the 1990s, Peter Walker in California, he began to experiment as well with materials, especially metals. This is an example of stainless steel. This is a fountain that he did in Los Angeles. And then for those that wanted to get away from the sort of flashy, shiny stainless steel, high-strength, low-alloy steel became popular. Weathering steel, the proprietary name is Core-10, and so everybody began to gravitate toward this sort of rustic, industrial, but beautiful at the same time material. This is Tom Oslin's a landscape architect. This is the steel is used as a containment for water. And then in France, Japolino steel, again, a material that a few years before was seen as inelegant and sort of crude. It's a galvanized steel. It's very industrial. It's used for things that you don't think of that would be good to be seen up close in the landscape. So this is a project she did. It's a stormwater channel, and those walls are made out of galvanized steel. And then cast aluminum. This is a West 8 project. We're into the time where digital simulations, digital design and fabrication has really opened up opportunities for us as landscape architects to create elements and components of our landscape that are very special, and it's a lot easier to make these things. This is an example of a digital simulation, and then this is an actual maquette that was in their office out of cast aluminum. And this is a close-up. It's actually a bridge rail in a park called Maxima Park in the Netherlands. They do a lot at West 8's office. They have an entire floor that's a shop. They have all kinds of machines, CNC milling machines and laser cutters. So they do a lot of physical one-to-one mock-ups of benches and different kinds of site furnishings, which is another big change. We do that a lot more. Michael Van Valkenburg does this a lot, and Hargreaves Associates. We always would use foam core or cardboard or something to make a maquette so we could look at it without actually building it. And now with rapid prototyping, 3D printing, it makes that process even easier. So one of my favorites is concrete. Concrete is some feel it's the ultimate modernist material. A lot of people avoid it because they, like galvanized steel, they feel that it's kind of crude and inelegant. But modernists and modern architects, of course, gravitated toward it because of its simplicity and the lines that can be made very clean. If you know the history of concrete, concrete and cement, Portland cement have been around since the Romans, but when people started to want to build buildings and bridges out of it, there was some people that started to experiment before engineering actually had the capacity to make calculations to figure out how strong the concrete was and if it's going to fall down or stand up. So this is a contractor. I don't know if you can see him. He's right here. He's showing that he trusts this concrete. This is the kind of test that he did. He would pour concrete and then measure the weight of bags of sand and stones or whatever. And when it would crack, then he would say, okay, that's the limit. It was a very hands-on kind of experimentation with structural integrity of concrete. So this was in the 1890s. His name was Hennebeck. I'm blanking out on his first name, but Hennebeck, I believe was his name. So how many of you know who invented reinforced concrete? Anybody? Well, there's in the literature, you'll see 3 people that are credited with figuring out how to use steel reinforcing in precast concrete. But this is very important. This guy, because he's an ancestor of us, he was a landscape gardener in France. His name is Joseph Monnier, and he's the guy that had the patent. And he, even though other people are I don't think that's working. We need a string from the top. Okay. All right. Anyway, he was a landscape gardener, and he's the guy that, because he was a landscape gardener, and that's where we came from as landscape architects, he even made bridges that are still standing. So he knew what he was doing, and the reason I say I want to give credit to him, not only because we can point, back and say it wasn't an engineer. It was a landscape architect, or the precursor to a landscape architect, that actually got the patent for it. So the record shows that Joseph Monnier has the patent for precast concrete. And these are the drawings from the patent office. So back to Fletcher Steel. The reason that Christina told me I should look at Fletcher Steel was his use of concrete. And his effort, and this effort has been going on forever, trying to make concrete look better and be more pleasing aesthetically. There's great architecture that's used it with very good formwork. If you have very fine formwork, then you can get a very nice finish on concrete. In the landscape, he was actually painting it. And this is Mabel Choate. This is the woman that was worked with him for 30 years. She was the woman who owned Nomkeg, and they had this relationship where they collaborated, and they're out painting one of his most famous pieces in that most famous garden of his. These are the blue steps, and you can see the concrete. It has a kind of a beige color, and then these little kind of grottos are painted in dark blue, so that it's very striking when you see the white and the green and the white of the birches, and then the blue that really stands out. So the modernists, back to California again, the quality of concrete that they appreciated the most was the fact that it's plastic. It can be formed in any if you can make a form, then the concrete will take that shape. And because they were looking at curvilinear forms, the concrete was the perfect material for them, because they could form it and make it into these beautiful curves, and they can also, that's pretty dark, but there were new pigments that you could add to concrete, either into the mix or you could add them onto the surface. And so the concrete was taking on this new image. You were able to color it. And then this is the Thomas Church's Donnell Garden. It's the pool, and his most famous garden. And the pool is probably the most photographed part of that project. And this is it in the 1990s. It's still owned by the family. It's only open to private groups, but I've been able to go there a couple of times. San Francisco is across the way there. The wetlands at the head of San Francisco Bay are just in the distance. So one thing that I found out about the modernists that were using concrete so much is that they were really not that knowledgeable of the concrete. This is a Thomas Church project. This is an article within the last 5 or 6 years. A landscape architect in California was hired to restore a couple of churches' gardens. And what they found was, this concrete was just, in really bad shape. And so as they looked at the details, the concrete slab had no reinforcing, and it was only 3.5 inches thick. And in my career, 5 is typical with reinforcing. But, we don't know at this point why, if it was expense, if they just didn't know and they thought, concrete is very strong, and so you don't have to compact the earth, you just pour it. But that was a real eye-opener because they used so much concrete. I thought, that they really knew what they were doing, but they were experimenting. And this was quite a few years ago. Another modernist in the Bay Area, Robert Royston, began to experiment with concrete by coloring it because these new colors were available. And he did a series of plazas with different. He treated them almost like Mondrian paintings. They were these beautiful plazas and courtyards of different colors. Oops. Exposed aggregate is another way that we've applied a surface texture. In the Mediterranean climate in California, where it's very mild, it works very well. It's not very good in cold climates like where I live. Concrete in general is not great. It's very inexpensive, but the icing salts will react with concrete and it fails. It doesn't have a long life, quite frankly. But in the West Coast, where it's mild, exposed aggregate is fairly common. And then Lawrence Halpern, the guy that started out by working for Thomas Church, I guess Peter Walker and Lawrence Halpern were probably the most prolific American landscape architects. Halpern lived into his 90s. He did many great projects around the country and around the world. In the 60s and 70s, he created what a lot of cultural critics said was some of the greatest civic fountains that had been done ever. And he used cast-in-place concrete because this was a material that he was familiar with because he was of that modernist era. And he created these fountains that are an abstraction of nature based on his familiarity with the mountains and the mountain streams and waterfalls in California. This is another project he did where he used cast-in-place concrete, and he used board finish using wooden boards as a form liner to get a different texture. And he did a simple thing. If you can see there's horizontal, and then there's vertical. And so in the working drawings for this project, there's 2 little diagrams that consist of about 5 parallel lines with dimensions. And that's the only information he gave the contractor is the board sizes and the size of the boards on one panel of concrete. And that's all he needed to build this very, very large project. It covers an expressway, a motorway in the city of Seattle. And then you see another interesting thing is he carried it all the way into the site furnishing, the trash receptacle. And today, Christina again was brilliant. She told me I should go to Blinken, yeah, sorry. I was just there. These are 3 hours old. A lot of similarities using concrete in a very simple yet elegant way in making the trash receptacles and making the light fixtures out of the same material. And this simple scoring on the concrete carries through. And the other thing that I really enjoyed about this project is the merging of the old and the new. You have such beautiful ground surfacing here. The pavements are spectacular. Coming from America, where any hand labor is outrageously expensive, we have trouble comprehending that you have people that can still do this today. And then this change of sort of the scale in the open, the very large blocks, and then the more intimate scale. When you're in a different part of this landscape, it's the same module but smaller and more intimate. That score line that's there that is following the score lines of the board finish on the building are very well done in my mind. So back to the U.S. This is what happened in the 60s and 70s in the U.S. This is concrete pavement that we used a lot. And we spent lots of time trying to figure out how to make it look better. We didn't color it, but we finished it with brooms and burlap bags and things that would give it a texture. And unfortunately, with concrete, with heavy use, with people walking on it, that texture eventually gets worn down. But that was this period of what I call convention, where nobody seemed to do very much innovative work. They just relied on the things that were the status quo, things that have been proven to work, concrete paving and brick paving. And these emanated from Hideo Sasaki, who taught at Harvard, and he started 2 or 3 different offices. Sasaki Walker, when he teamed up with Peter Walker on the West Coast, and that eventually became SWA Group. Peter Walker sold his interest and started his own practice again several times. But now we can make translucent concrete. We can put glass rods and cast concrete and have this beautiful effect. Very expensive. Even today, I think when I first discovered this, there was only one manufacturer in Europe, and I think there's at least 2 now. But I remember my students were trying to get a sample, and just a small sample piece was, I think, $2,000 at the time. Obviously too expensive for a student project. This is the only American application that I know of. You may know of some in Europe. I would think it's much more reasonable in price over here. This is a war memorial down in Louisiana. And you can see that it has to be used very sparingly, but to great effect. So, anybody know what photocatalytic concrete is? Anybody heard of that? This is a fantastic discovery. In the 70s, some chemists discovered that you could, titanium oxide was a catalyst, and you could coat things with it. You could actually mix it into concrete and cast concrete. And what this does is it absorbs airborne pollutants. It neutralizes carbon and other things that are in the air, and it is self-cleaning. It's not like all the carbon sticks to it and it turns black, but it's a chemical process. And this is my students' research, by the way. That's one thing that we do in our materials classes is have students look at any sort of new material that's out there that might be of interest to landscape architects. This is a highway sound barrier wall, but it's made out of this photocatalytic concrete, so it can slow the noise a little, and it also helps to clear the air. And then we can even buy pavers now that are impregnated with this catalyst in the U.S. So I mentioned digital design and fabrication. The advent of computers and now machines that can make things based on a computer drawing. Our architecture is far ahead of us, but we're beginning to catch up with it. These are some images from West 8's office. This is part of their shop. There's so many scales that we can work at three-dimensionally, from the 3D printers of very small maquettes to full-size. And you can see this is a scale model. This is one-to-one. And he was one of the first people to use polyester reinforced concrete or fiber reinforced concrete, something that's very thin and very strong, and it can be cast with in interesting shapes. This is a 3D printed piece here. You can see several different little maquettes that they made with a 3D printer to test what eventually is drawn in 3D software, and then these renderings that show this very large precast concrete trellis that is a major element in Maximum Park in the Netherlands. And one of the issues with photomontage and Photoshop drawings is that it's hard to tell, is that real, is that real? This one is real, but that's not, that's a drawing. So that's one of the dangers, because clients see things and you do a rendering long before you figure out the details and how to make it. And they think it's finished, and they're like, oh yeah, just give this to the contractor and we'll be fine. And so, as I said, this place has incredible history of pavements, and I thought this was interesting. This is at the Expo '98. This is a kind of contemporary, supposed to be reinforced turf. That's supposed to have grass in between, but it's a series of precast elements that you can lock together. And I thought it's an interesting contrast with your kind of typical limestone and basalt mosaic pavement. And this has been around for many years. This is Bout Chaumont in Paris, 19th century park. They were casting concrete and making molds of tree limbs and stumps and creating these things long ago. So stone, this is an interesting take on stone. It's not granite or limestone. But Fletcher Steele, another thing that he did that I discovered this summer is that he used anthracite coal in the garden as a ground surface material. This is an old photograph of a piece of the Nomkeg estate called the Afternoon Garden. There's a reflecting pool here and 4 little basins of water. And this is anthracite coal pieces between a small boxwood hedge. The only other person that I'd ever heard of that actually used coal was an architect called Bruce Goff that worked in Oklahoma in the U.S. This is a residential building. This is actually, that's a polished concrete floor. He would find these old large chunks of colored glass, the glass that hardened in the bottom of the big foundry bowl that was used to pour it into molds, and he would work that into his architecture. These are all very large chunks of anthracite coal that are cut into building stone pieces, and then he would place the glass into that wall so that you could get light coming through. And then this is the recent photo. This was last fall. This is the Afternoon Garden with the anthracite coal. The Nomkeg estate was restored just about a year ago. So you can see a close-up. What Fletcher Steele was looking for was something to contrast the pink crushed granite that was the pavement around the fountain basin. And so this blue-black anthracite coal was the thing that he decided to use, and they've restored it and brought it back, so it's actually very beautiful. The client, Mabel Choate, did a lecture at the Garden Club, and this is her lecture notes from that 1938 called Cold in My Garden, and she describes the story of how they tried several things. They couldn't come up with the right ground surface material, and they came out with Fletcher steel and decided that it would be coal, and she thought it was a brilliant idea. And so a landscape architect by the name of Ron Henderson in Providence, Rhode Island, had read about this, and so he got a copy of those notes, and he tried to convince a client to let him use coal in their garden. You know, people think of coal as black and dirty and a fuel, right? So he showed it to his client, and she thought, okay, let's take a look. And he did this beautiful garden that has granite and this very finely crushed anthracite coal as a ground surface material. Wood, if we go back to the modernists, like Thomas Church, very simple technology like saws that can cut curves. He managed to combine this love of the curvilinear with a material that is rectilinear in its module. And so he would start with variation on these square components, but then he was able to actually introduce a curve into the material that usually was not curved. And so we've advanced far beyond that. This is the Yokohama terminal, where wood, it maintains its modularity, but it not only is a horizontal surface, it can become an angled surface, it can become a ramp, become stairs, can actually become an extension of the landform. And then because of AutoCAD and how we can do framing plans, and we don't have to do the tedious calculations to figure out how to make a surface of wood seem almost like it's curvilinear when it really isn't. It's actually because of the framing, and there's very little bending in it, so that the wood maintains its shape, but you can develop these surfaces that are very different from what we're used to. This, by the way, you could never do this in the United States. There would be 3 lawyers over here ready to sue, because you can see there's a little kid that's falling down. We would have rails all over it, and lawyers ready to sue. Bamboo is as we turn to more sustainable materials. I mentioned concrete. Concrete is it's sustainable in that it's usually local, because aggregates are local, because we can't transport concrete very far. But the real unsustainable part is the Portland cement and the embodied energy that it takes to cook it and to make it. And a lot of advances are being made in terms of substitutes for Portland cement to make it more sustainable. Wood, we've gravitated a lot in the U.S. toward tropical hardwoods like Ipe and Kamaru. Those are fantastic, but because they last for so long. But it's very difficult to know if these things were sustainably harvested. There's a lot of corruption. And so bamboo is another thing that people have started to think about, because bamboo is so fast growing that we can make these composites like this, but they didn't work very well on the outside in the landscape. So now there's a process whereby they can be fired in a kiln, and the sugars in the bamboo harden and coalesce and make it a very hard and durable surface for the outdoors. As I mentioned, rapid prototyping, 3D printing. This is a project in Chris Reed's office, Stops Landscape Urbanism in Boston. This is for a project on the Harvard campus in a primary plaza there. This is a bench. It's so easy to do many variations, and as we test different shapes and different sizes, this is one of the ways to start at a very small scale. And then this is the project of primarily wood pieces that are created with machinery that are operated through the computer drawings that are developed by the designer. And this is a James Corner Field Operations roof garden in New York City, another example of how we can create things out of wood that we could never do before. This new technology allowed us to be able to do computer drawings, three-dimensional drawings, and then it drives a machine that actually cuts and forms the wood. This is a project that my office did in Boston. It's the first green residential building in Boston. It's called the McAllen Building. There's a film called The Greening of Southie. It's in the Southie or South Boston, at one time a heavily Irish neighborhood. So this is a high-rise residential building with extensive green roof on the top, a roof garden, or an intensive green roof as we call it today, on the fourth level, and then a plaza at the bottom. And I'm primarily showing this because of wood. This is wood decking. This is porous pavement, unit pavers. Same pavers that are on the plaza level and below, so the water infiltrates between the pavers and goes into the ground. All the water that falls at this level either goes into the soil and is collected if it makes it through, and it passes through here and here, and that goes into a cistern, and the cistern, all the water that's collected from rainfall, gets used for irrigation. This is, if you can see these really tiny, we needed a tree or something that was tree-like, but it's so windy and it's difficult on a roof garden with the soil depth. We went with the native sumac, Rus typhon, I think. I don't know if you know sumac, if that grows here, but it's a kind of weedy shrub, large, small tree, large shrub. And most people thought we were crazy, and you can plant them in the very small. You see these little openings in the pool deck. But this is what it looks like now. They grew, and they were very happy there. The wind didn't bother them. The very little soil didn't seem to bother them. But then the decking is used, instead of bringing in a different material for seating and putting chairs and tables. We took that same wood. It was going to be Ipe, but the client wanted to save money, and so we went with Camaro, which is another tropical hardwood. Most of people are not using Ipe anymore in the U.S. There's a move to use recycled woods like teak, because Ipe it's getting a bad reputation in terms of not being very sustainable. To cut this wood from the tropics and ship it to the U.S. And it's just another photograph of the deck. Rubber and plastics. This is something that I don't know a lot about. I'm very interested in it for this one particular project. This is another research project by one of my students. They have to look at the history and sort of properties of these materials, and then find precedents. Have they been used? And this is another Chris Reed landscape urbanism project. This is recycled automobile tires and sneaker soles. The rubber from the bottom of your shoes, they crush it into a fine kind of granular material and mix it with epoxies, and then it can be poured like asphalt. And this is, it's too bad you can't see that very well. This is the Urban Lounge in Switzerland. They covered the entire plaza, and they made these shades for sitting, and even a basin of water. And it's liquid applied. It's applied like asphalt, and so then it creates this kind of rubbery surface that's, in this case, very, very colorful. Martha Schwartz introduced colored acrylic back in the 80s in the U.S. This was the importance of this, and landscape architecture in the U.S. is that we had this period of just bricks and concrete and nothing very interesting and innovative. So she's trained as an artist and a landscape architect. So she did a small garden for her mother in Philadelphia, where she took broken pieces of plexiglass or colored acrylic. And it was more of an art installation, and it was a relatively temporary. She and her mother didn't live there for very long. But another landscape architect from the University of Massachusetts, Dean Cardesis, did a much more elegant garden where he used these acrylic panels to provide separation in a very banal suburban garden. And then Peter Walker started to experiment with fiberglass, because fiberglass can be made to be translucent. And so he created these artificial stones, and he would, when he reinvented himself and began to follow the principles of minimalist art in landscape, where seriality, repetition, and flatness were the kind of key things that he tried to do. He would make grids and line up stones that were all the same, or flower pots or whatever. In these days, in the 90s, he was doing a lot of experimentation. And so he made these glowing rocks that looked like rocks during the day, but at night they had the light inside and made them glow. And acrylic also incorporated, this is another Landmark Studio project on a small courtyard. This idea of being able to make things glow and to provide a light source that doesn't hit you in the eyes. It's not, it doesn't glare. It just glows, so there's a very soft light. And that's one of the things about acrylic that is very interesting to me and a lot of other people. And speaking of acrylic, this is a project in Washington, D.C. that we did 2 or 3 years ago. It's a residential high-rise with a courtyard in the center. And it's actually a green roof because it's over a parking garage, but it's at grade level. And so when you enter, this is the street, and this is the building that's U-shaped, and then eventually there's going to be a building here. So you enter here and you go through a lobby. You can see here, this is the main entrance. We worked with the interior designers. They were doing these aluminum screens and sort of dividers to divide the different program areas in the lobby and in the computer room and the exercise room that were all common space on the ground level. And so for the garden, we picked up on that geometry. The client wanted something that would make a small space seem bigger, so we had to figure out a way to mound up the earth and plant it, but also create spaces where people could have an intimate conversation, or they could have a group. There's an outdoor kitchen, and so people are going to be cooking and eating. And so there's a series of pods with a concrete wall that has a draped white acrylic sheet over it that could be backlit so that it would glow, and again provide a soft light that would be fine for being able to see your way around, but it wouldn't be too bright to make it uncomfortable. So this is actually a rendering from early on with these glowing walls with people sitting up against them. This is these different pods. You can see the earth is mounded up because we had very little space, and we had to use foam insulation so that you could make sure that the weight of soil was not too much for the structure. And we also had to figure out how do we make this really weird curving bench. We needed a material that could curve in 2 dimensions, 2 directions, and we knew it was too difficult to cast it in concrete. We thought about wood, and so we ended up. And also, how do you fit these pieces together? You've got to fabricate the sort of wedge-shaped pieces as the walls curve. And we went through many different studies, and so we ended up with solid surface acrylic, which is the proprietary name in the US is Corian. The DuPont chemical company makes it. It's made for kitchen countertops. This, according to DuPont, this is the first exterior application. And they were doing a case study 2 years ago. I'm not sure what's happened, I've lost touch with it. But the interesting thing about this, again, this ability to collaborate with fabricators really opens up new avenues for designers and how we can experiment in tandem with the people that actually know how to build this stuff. These are all done by the fabricator. Those aren't designer drawings. We gave them Lino 3D models and a couple of details like this. And they produce these because they work at 4 decimal places in their computer programs. This stuff is incredibly accurate, far more accurate than what we normally work in. And so after a certain stage of the project, we do these full-scale mock-ups so that, I know that's very dark, but we had to figure out the right curve and the sort of comfort of being able to sit on these benches. This is how this stuff is thermoformed. It comes in big sheets like plywood, 4x8 or 5x10. And it's passed through an oven, and it warms it, and then the sheets are dry. They stack up MDF, medium density fiberboard. They glue that together, and then their CNC router, using a computer generated drawing, will shape it like that. So then the big piece of acrylic is dropped into that, and they use air-filled bladders, and these bladders push, just like you would sort of push a pie crust into a dish so that it takes the shape of the mold. And then that's how, this is a screenshot of the computer as it was operating, cutting these shapes. The piece would go in as a rectangle, but then the machine would then cut the edges so that the four edges of this thing that had to be cut to fit together were done by the computer and the CNC milling machine. There it is. You can see it's cutting those edges off. And so the owner wanted something that you could enjoy from up above when you're in your apartment, as well as being down in the landscape. And they wanted a landscape to seem bigger than its actual dimensions, because it's a very small courtyard. And then there's a media screen so that there's movies occasionally. And this is mostly marketed to young people, the 30-year-olds that are living in the city and have careers. And they wanted a place for socialization, for meeting people and enjoying life in the city. And this is what it looks like during the daytime. And then one of the pods at night. So I think most critics would agree that the best work is that work that's grounded in history and theory. And my hope is that in finding this sort of trajectory of innovation followed by convention, followed by innovation again, I'm trying to learn what sort of spurred the innovation, what was the reason behind lack of innovation, and there's several sort of ideas I have, but I haven't arrived at any conclusion. But the hope is that as people learn about this history of material innovation leading up to the present day, then we'll be able to do even greater things in terms of innovative material use in the future. Thank you.
Does this research that you are starting or working in materials as afterlife of the materials after being engaging in the building process?
Yeah, that's one of the things that one of the most important things as landscape architects that we have to deal with is maintenance, or in America, lack thereof. And we're always we have money to build new landscapes, but very rarely does anybody have the money for maintenance. If you take, for example, the High Line in New York, and we talked about this in the class, that there is an effort in the U.S. to have public-private partnerships. And the problem with that is that we're taking away the public commons. You know, it's the High Line and Bryant Park are all private, and they can be closed at any time. But the maintenance is very good, and it's most people have decided it's a fact of life that we can't get away from it. But then the other part of that is when you experiment with new materials, there's a danger that it might be a bad experiment, and clients don't like to see things fail. They're paying us as experts, and so there has to be a balance, right? Because a really good client will allow a certain amount of experimentation within limits. And so that's a point, it's a very good point, because of the acrylic / project. And we were concerned about, especially the material that hadn't been used outside. And so far, it seems to be weathered very well. But it's also enclosed, it's protected somewhat. So that's a big issue, and it's a thing that we're trying to address in the U.S. in designing things that are more durable and will last longer. I mean, that's why people used large stone and things that were renewed over time that were going to last for a long time. So it's a struggle, and it's a matter of balance. So, what we do next.
So that's for rubber, the seats were made that also. Is that triangle, the one that goes through?
You mean the red
Yes,
in
yes.
Switzerland? That's a good question. I don't think so, because there's the basin of water that made a fountain out of the same stuff. There is rubber pavement now that will infiltrate water, but I don't think that does. But I don't really know. I haven't seen it. I haven't been there. But I think it was before this new manufacturing of the rubber that will drain. We now, in the U.S., people are putting it around trees on the sidewalk in cities, so that it's a soft pavement, but the water goes through. And that's somewhat experimental. It'll be a few more years before we